Hello everyone, this is Ajay B, studying in Sri Venkateswara College of Engineering in the Department of Computer Science and Artificial Intelligence. So the topic we'll be discussing, which is related to the course Data Science, and the topic is about the introduction to continuous distributions. Continuous distributions are used to model data that can take on any value within a range. They are often used in statistics and probability theory to describe phenomena such as height, weight, and temperature. Probability density function, which is also known as PDF. The PDF defines the probability of a random variable taking on a particular value. It is a function that integrates to 1 over the entire range of the random variable, which also have three stages. That is, one is shape and the area and maximum. Coming to the shape of the PDF can be symmetrical and skewed depending on the distribution. The area under the PDF curve represents the probability of the random variable falling within the certain range, and the maximum value of the PDF corresponds to the most likely the value of random variable. Like you can see in the picture, the bell curve, the standard normal bell curve is which shows the data that vary randomly from the mean, and the normal curve is the pattern the data form is like a bell-shaped curve. Cumulative distribution function, which is CDF. The CDF gives the probability that a random variable is less than or equal to a certain value. It is a non-decreasing function that ranges from 0 to 1. The definition of CDF is the integral of the PDF up to a given value. Interpretation: the CDF represents the cumulative probability of the random variable up to a specific point. And the applications are: the CDF is used to calculate probability, percentiles, and expected values. The continuous distributions, which are common. There are many different types of continuous distributions, each with its unique characteristics and applications. Some common examples include the normal and exponential and uniform distributions. The normal distribution is a bell-shaped curve symmetric around the mean, and the exponential distribution is skewed to the right and models waiting times for a lifetimes. Coming to the uniform distribution, it is in rectangular shape and equal probabilities. Measures of the central tendency and dispersion. To understand and compare continuous distributions, we use measures like the mean, median, and standard deviation. Coming to the mean, which means it's the average value. The interpretation of mean is the center of the distribution, whereas the median, which is also known as the middle value, and the interpretation is 50% of the values are above or below. Standard deviation is the spread of data. Applications of continuous distributions. Continuous distributions are widely used in the various fields, including finance, engineering, and healthcare. In finance, modeling stock prices and risks. In engineering, analyzing the reliability of systems. In healthcare, understanding the patient outcomes. Estimation and interference. Like using data from a sample, we can estimate the parameters of a continuous distribution and make inferences about the population. Parameter estimation, like using sample data to estimate the mean, standard, and the mean and standard deviation, etc. And the hypothesis testing is like testing claims about the population parameters, like based on sample data. And the confidence intervals is estimating a range of uh, possible values of for a population parameter. Coming to the conclusion, like we'll know the key and takeaways. Continuous distribution are fundamental tools in statistics and probability theory, enabling us to model and understand real-world phenomena. Understanding PDFs and CDFs are like essential for working with continuous distributions. The common distributions, knowing different distributions and their properties, and applications are understanding how distributions are used in different fields and estimation and interference.